Voyager 1's recent re-entry into beaming useful data is like a recalcitrant, unlikely miracle, the kind of engineering legend trainees will reference when they require evidence that human ingenuity obstinately refuses to accept the term impossible. Launched in 1977 as part of a mission no one envisioned would extend longer than a few years, Voyager 1 flew quietly into the farthest reaches of the human-made world and, decades after exploring the solar system and beyond, became the first to press beyond the heliosphere into the unknown and continue whispering back to Earth. For half a century it has endured environments no engineer in the 1970s could have fully anticipated. Radiation belts around Jupiter that would scorch modern electronics in minutes, the bitter cold of deep space where temperatures and particle environments are measured in ways that make terrestrial weather seem tame, and the steady attrition of time on a nuclear battery that gives only a slow, dwindling trickle of power. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. The probes were built with less memory than a watch and computing power slimmer than a pocket calculator, yet their design, brilliant, austere, and singular, meant that every byte and every joule counted. Voyager's sensors showed us things the textbooks never anticipated: volcanic eruptions on Jupiter's moon Io that shoot molten lava into space, Saturn's intricate, braided rings and Titan's dense, organic-laden atmosphere that suggest prebiotic chemistry, the skewed tilt and bear, peculiarity of Uranus's magnetism, and Neptune's supersonic winds and geyser-spewing moon Triton. With each new discovery, the reach of what a man-made machine could perceive was pushed further, and scientists learned how little they knew about the cosmic neighborhood. And then, years after their 5-year mission and well beyond the times when managers flatly assumed either probe was still alive, the two Voyagers traversed the invisible, hypothetical edge we term the heliopause, the area where the sun's outgoing solar wind converges with the tenuous gas and magnetic fields of interstellar space, and discovered that the boundary of our solar system was not a tidy border but a tangled, creased, dynamic region of folds and streams and surprises. Voyager 1's findings outside the heliosphere depicted a scene of tight, compressed pockets of interstellar particles, invisible walls and folds that occasionally pursued the probe, while Voyager 2 encountered long-stretched flows and a much hotter-than-predicted plasma environment, two doors, two different exits into an area ruled by laws older and stranger than our simulations predicted. And then the scare: in late 2022 Voyager 1 signals started coming in as gibberish, strings of ones and zeros organized in patterns nobody could decipher, a signal that was physically making it to Earth but logically incomprehensible, as if some small, essential programming set within the probe had been rendered into a language the ground systems could no longer understand. Diagnostics targeted the flight data subsystem, an old computer where a small memory area had probably been altered by a cosmic ray or high-energy particle, the same kind of radiation that the craft had been subjected to for decades. Deep space has no atmosphere to protect electronics, and energetic particles can flip bits, corrupt memory, and mangle the few precious instructions that make a spacecraft make sense. This wasn't something you could resolve by replacing a component. There was no rescue mission, no spare motherboard on orbit. The JPL engineers were confronted with the ridiculous, ominous possibility of rewriting a machine over 15 billion miles away, using documentation written in another age, on equipment for which replacement parts no longer existed, and with the help of a few experts, many of whom were the same engineers who had guided the mission decades before. The deadline for any mistake was not minutes but 22-hour light delays. Each command took virtually a day to reach Voyager and another day for an answer to return, so each try had to be exact, for a single wrong move would give the mission eternal silence. What came next was laborious, bordering on ritual. Teams burrowed through ancient manuals and schematics, reverse-engineered memory maps, translated contemporary intentions into brute binary patterns that the spacecraft would comprehend, and chopped these orders into messages small enough to be transmitted via radio but dense enough to rebuild entire operational behaviors onto a machine born in an analog world. They redrew code line by line and, since much of the probe's software and hardware was stuck in amber, they needed to reuse unused memory spaces and redirect vital functions away from the handful of dirty bits. It's a remote surgery performed with pure math and patience. Finally, after weeks of experimentation, mistakes, and days of endless silence, another signal came back, clean, organized, intelligible. Voyager 1 had rebooted its system. A kilobyte memory-powered spacecraft had executed a task its creators had never envisioned would be needed, and it succeeded. That was not just a technical triumph, it was symbolic. Here was a machine that had lived beyond the expectations of its makers, weathered a lethal environment, and then was brought back from the edge by a group representing the persistence and continuity of human learning. The fix highlighted how delicate and astonishing the probes are: nuclear batteries slowly leaking power over decades, instruments shut down one at a time in order to conserve energy, and a communications link that becomes slower and weaker with distance. NASA has been systematically shutting down non-essential systems in order to extend the probe's lifetimes well into the 2030s when, quite likely, the transmitters will go dark. Even so, the Voyagers will not halt. They will continue coasting through interstellar space for millennia, with a gold disk, the golden record, attached like a human autograph to their hull. Designed by Carl Sagan, Timothy Ferris, and a small, diverse group of artists, musicians, linguists, and scientists, the golden record was never so much a practical signal to other civilizations as it was an act of significance, a 12-inch disk inscribed with sounds, images, and diagrams designed to give a mathematical and cultural snapshot of Earth and humankind to whoever or whatever, whenever, might encounter it. It has dozens of languages of greeting, music of many nations, sounds of nature, and diagrams that instruct an alien mind how to play it back, as well as where to locate our system in the galaxy with pulsar maps. The chance that someone will stumble upon it is infinitesimal, a small metal breath in an infinite blackness, but the record's purpose was less about communication and more about validation, an act that announced, in effect, we were here. We believed it was important to leave something behind. The Voyager narrative is stitched through with ironies and invigorating realities. The probes were not constructed to be fixed from light years away, they were made to be elementary, durable, and effective for a task that was going to take a few years. The same limitations, limited memory, uncomplicated hardware, and a lack of redundant contemporary complication, are what allowed them to be suited to the type of binary triage engineers could bring to bear decades later. The mission that was started as a neat planetary reconnaissance evolved, due to accident and meticulous design, into the longest-running space mission in history and a continuing experiment in how much human creativity can be pushed when constrained by patience, institutional memory, and a commitment to learn from error. The Voyagers uncovered not only the physical features of distant worlds but also how little the greatest models understood about the boundary between our star's realm and the interstellar medium: heliosphere folds that swell and recede like a skin, blobs of denser particles that the probes read differently because they're in slightly different places, magnetic fields twisting and folding in ways that strain simulation. Voyager 1's plasma instrument broke many years ago, and there have been holes in the types of direct measurements that scientists would prefer, but Voyager 2's operational sensors provided the complement, detecting a surprisingly warm, thin plasma and putting into perspective the magnetic and energetic anomalies at the boundary. Together, the two travelers are like a pair of ears hearing the bizarre hum of space. Their conflicting readings instruct us that space is not homogeneous and that the reach of the solar system is complicated by waves and shocks and structures driven by both local and galactic scale forces. The information Voyager sends back, now interpretable once more after the meticulous repair, are not just figures for experts to decipher. They are an ongoing story of human engagement with the universe, a chronicle of daring that started as a daring tour of the planets and evolved into an epic-making journey to a destination no one had ever visited. The power failure of the probes ultimately will be lamented by public and engineers both, but the possibility of those metal relics flowing silently away with a human mixtape and a list of our scientific hard-won knowledge is strangely comforting. Even if no other civilization ever hears the record, we already did. We listened to the universe and responded. And though each instrument shutting down chips away at our capacity to directly study the interstellar medium, the work that gets done, the pictures, the magnetometer data, the plasma diagnostics, and simply fixing a machine 15 billion miles away, pushes the limits of what exploration in the 21st century even looks like. If the edge of our cosmic neighborhood isn't the finish line but the start of something odder, then Voyager 1 is a reminder that beginnings are sloppy, recalcitrant, and lovely, a battered probe, a fingernail-sized chip of material pummeled by cosmic rays, a group of engineers decoding decades of glue logic into a lifeline, and a golden record that is more an insistence that we reached out than a beacon. In that way, every rational calculation and every unlikely repair is one step in a grander human drive, to reach, to document, to mend, and to continue listening as long as there is power to carry a whisper back across the black.